Thank you, Nathan, and thank you for the invitation to come speak. You guys have hung in there for a big day. I do want to thank the Glen Canyon Conservancy. Amanda here was the one who initially contacted me. I think I got her email when I was in Antarctica leading a group there, but we said yes. And Nathan, thank you very much for making it possible for me to come here and speak at Grand Staircase. And I'm a very fortunate person. I was guiding trips for the Museum of Northern Arizona before it was a monument. And then when it was made a monument, I got to go to the South Rim and watch it happen. I took these photographs on September 18th, 1996. A couple of young guys there sitting on the rim of the Grand Canyon. This was right in front of the El Tovar Hotel. I've been thinking about contributing these photographs to the National Monument. They probably have some photographs of that day. Terry Tempest Williams spoke at that event. There was this guy, this ruddy-looking guy who gave a speech there. It was kind of a big deal when it was created because it was the first national monument that the BLM was going to manage. And then this is the speech that Bill Clinton gave when he made the monument. And what was really interesting about being there that day is that this was before 9/11. And so the Secret Service was there and it set up a portable sort of security thing. And you could walk through this cheap little metal detector, and they were looking at backpacks. And I heard one of the Secret Service guys whisper to the other as I went through. He said, "What's with all these backpacks?" And these are Secret Service guys that are used to going to Philadelphia and Boston and Chicago. They hadn't been out west and really know what was going on. As I was leaving the event, I was just walking behind the El Tovar and I stepped out in front of an SUV. And, you know, I had to step back because it almost hit me. And as it went by, it was Bill Clinton and Al Gore sitting in the back seat of the SUV. So it was a very different time back then. Anyway, I'm happy to announce that our book is going to be in a fully revised second edition. And this is going to be the new cover of the book. We put a Pennsylvania age map on it and took the Dakota sandstone map off of it. But this is something I've been working on for the last year with Ron Blakey. And just to show you some of the changes, all of the paleogeographic maps are going to move to their own separate section in the book. And you'll be able to turn the page sequentially and see one map right after the other. So you can actually use it like a flip book when you go through it. But the other neat thing is that everything regarding that map will be explained right on the page there. Before you would go through the book and you'd see the map, but you had to hunt through the text to try to find where the text was for that particular map. So we are just finishing up this week. We're hoping to send it to the printer within the next 2 weeks. And so maybe by the time springtime comes, this book will be available for all of you. So this is the area that we're talking about here, the Colorado Plateau. I think you guys have heard a lot about that already this morning, and there's the National Monument superimposed on it. So the Staircase Monument is not exactly in the heart of the Colorado Plateau, but it does contain a fantastic section of rock. And that's something I want to talk about. A lot of times when I'm out in the field, I will ask people where they're from, and then I will place them where they're from on this map of physiographic provinces. And did you know that if our country had been divided up into states based on its distinct geography, we'd have 26 states or 25 states. You can see them listed here. Out here, out west, those are the 3 provinces that are the most important to us. Obviously, the Colorado Plateau, but to the west and south is the Basin and Range, and to the north and east is the Rocky Mountains. Now, in the geologic past, these were not separate provinces, and there would have been different provinces in the past. And these have been differentiated. First, the Rocky Mountains became differentiated from the plateau about 60 or 70 million years ago. And the Basin and Range is only about 20 million years old. And there is plateau rocks that sit out in the Basin and Range, but they've been faulted and deformed, and so it doesn't look like the Colorado Plateau out there. In fact, the very famous Claron Formation that makes up the hoodoos at Bryce Canyon National Park and Cedar Breaks, Claron is actually the type section for that rock unit is out in the Basin and Range. and it's heavily faulted out there. So this is the namesake for the western part of the monument. I drove by there this morning, Lefevre overlooked on US Highway 89A, and we will just put the training wheels in there, the chocolate cliffs, vermilion cliffs, the Wright cliffs, the gray cliffs, and the pink cliffs. It's kind of a stretch to call them the gray cliffs. They really don't form cliffs in that view right there. They're covered in the trees right there, but that's a good view of the western part of the monument. And what I want to talk about today are these three things: rocks, uplift, and erosion. That's really the whole story here. Some of you are challenged a little bit to talk about geology. This is a shortcut you can do. You can say we can talk about the long history of the monument, which is the deposition of the rocks. We can talk about the moderate age of the monument, which is the uplift. Or we can talk about the erosion, which is the most recent thing to happen in the monument. And a few years back, the interpretive rangers at Bryce Canyon National Park, they came up with the acronym SUE, sedimentation, uplift, and erosion. Some of you have probably heard that. And then the Grand Canyon interpretive rangers came up with deposition, uplift, denudation, and erosion, or hey dude, get real about geology. And so these are some of the acronyms. But I just thought for our purposes this afternoon we do rocks, uplift, and erosion. The majority of this talk is about the rocks. And this is from Ancient Landscapes of the Colorado Plateau, and this is the entire 3-mile stack. Even in that photograph that I showed you, you cannot see this entire stack of rocks. And if we were to say, oh, I got the same thing up on top there. In the book, it's actually at the bottom of the diagram. But this is extremely vertically exaggerated. This is 3 miles from top to bottom, but the distance here represents about 80 miles. If you look at the top diagram, you can see the black bars over there. 10 miles is across there, and then up and down is 1 mile. So the vertical exaggeration is 1.5 times, even on the top one there. But still, going from left to right, you're slowly from the bottom of the Grand Canyon going up a staircase or a stairway towards the north until you get to Bryce Canyon. And for many years, I was a trail guide at the Grand Canyon, and we'd be hiking out from Phantom Ranch, and it's 8 miles on the Bright Angel Trail, and we'd get near the top, and people would just be dead dog tired. And we get up here to the 1.5 mile house, and I pull out this diagram, and I would say to them, be thankful you didn't do this hike 50 million years ago. You still have 2/3 of the way to go. And so, all of that stuff that we see in Grand Staircase Escalante National Monument, right here, has the Grand Canyon rocks below. So the future for the monument is very bright, because there's a lot of rocks that are going to be there. This is what we see at Zion National Park, and the rocks are still buried here. The Grand Canyon section is still buried. The Bryce section is already eroded away. And then at Bryce Canyon, this is what you see. And what's really interesting, if you stand on the rim of Bryce, you're at 8,000 feet. You can ask anybody who's with you, did you go to the Grand Canyon? And believe it or not, these layers that are in the Grand Canyon are below sea level at Bryce, deeply buried by these other rocks. The reason for that is because of the dip in the rocks. The rocks are actually dipping down to the north, and it doesn't take much of a dip for layers of rock that are at the surface of the Grand Canyon to be almost 2 miles buried once you get to Bryce Canyon. So this is what you see in Grand Staircase Escalante. A lot of the Grand Canyon section is still buried, but in a few places we still have the rim rocks of the Grand Canyon that are exposed, and of course we go all the way up to the pink cliffs for the most part. And there you have it all right there. So over in the lower left there are the basement rocks of the Colorado Plateau. And even though we do not have basement rocks exposed in the National Monument, they are there nonetheless. We know that those rock layers are there. This would be the bottom of that previous diagram where you see the bottom of the Grand Canyon, and it's cutting through the whole Paleozoic section. We know that they're underneath Grand Staircase because we've sampled the rocks down below. Also, to the east of the monument, this is in Westwater Canyon near Moab, Utah. These are the same basement rocks that come to the surface right at the Colorado River in Westwater Canyon. So the entire southwest is underlain by these metamorphic and igneous rocks that we call it the basement. All continents have a basement, and then sedimentary rocks are deposited on top. By the way, this is a much greater unconformity than the one in the Grand Canyon. The one in the Grand Canyon has basement rocks covered by sediments that are 500 million years old. This layer, the Chin Lee, is only about 200. So this is even a greater unconformity than the one the Grand Canyon brags about. So in the new book, oh yeah, here's some training wheels for what you're going to see. I just want to go back and do that for you once again. I'm not going to have these on all the paleogeographic maps, but the paleogeographic maps I'm going to show you have this same scale to them. And if you go back 1,700 million years ago, this is what the Southwest looked like. And even when Alan was showing the paleogeographic maps, you should realize that on all of these maps, there's climate information that's embedded in the maps. Notice that these are all earth tones here. 1,700 million years ago, I think Mark would be very, very upset because there's no plants growing on the surface of the earth. Anything that's alive is in oceans at this time. To me, this is earthly paradise. There's no bothersome vegetation. You can see everything. Of course, even with the plants that we do have today, we still have rocks poking through the biological soil. So this is still a paradise here in the National Monument. Anyway, the big story about the basement is that there were these strings of volcanic islands, much like Japan and the Philippines are today. And by plate tectonic processes, they were drifting from the south and attaching themselves to North America. So sequentially through time, we added real estate to the North American continent. And if you ever have real estate brokers with you on your trips, use that word, adding real estate to the continent. And they'll get very excited and they'll say, oh, can we have more of that? Can we add more land? Let's put a little land next to Los Angeles. Anyway, that's how this formed right here. You won't see these rocks in the monument, but just know that they're there. Now this is the kind of diagram right here that puts prospective geology students to sleep. But it's just a stack in the monument from the Kaibab limestone at the bottom, and then we have the Claron Formation up at the top. And this is a useful diagram because it has the millions of years ago. The figures in here actually represent rock types. You can tell which rock type is in there. And then it gives the relative thicknesses of all these formations as well. And this is just the names of some of the important ones that I will show you maps for this afternoon. We don't have time to talk about every single layer. So the Kaibab Formation, it forms the rim of the Grand Canyon. It was deposited in a shallow seaway, and you'll notice that very carefully the coastline of North America was drawn right about where the Colorado River comes through Glen Canyon today. The reason for that is when you go east of this line on the modern landscape, there is no Kaibab limestone over here. This is where Monument Valley is located today, and there is no Kaibab limestone in Monument Valley. So just so you understand, when you're using these maps, some of these boundaries between land and ocean are actually well-known ideas that are not just willy-nilly put onto the map. We actually know that they're there. And the Kaibab Formation is seen in a very few places, only in the uplifted core of the Circle Cliffs upward. I got really excited when we went on the Wolverine Loop Road and saw the Kaibab limestone, and then also in the Buckskin Gulch area near Coyote Buttes. It is present throughout the entire monument, but only at the subsurface. And now the Chin Lee Formation, one of the most exciting rock units in the monument. You can see There's a lot more green here for Mark. This was a semi-tropical area at the time, and there were huge river systems that were making their way from the southeast towards the northwest. These are the rivers where the petrified logs of the Chinle Formation originated. So there might have been riparian vegetation that was growing along these rivers. Notice this volcanic arc that's right here. These are all volcanoes as well. When these volcanoes would blow up, silica-rich ash would come into the river system, bury the logs, and that's how the logs became silicified, being buried in volcanic ash. The ash would dissolve and replace carbon atoms at the atomic level. So carbon atoms replaced by silica. Fantastic exposures within the monument, also ringing the circle cliffs upward and right near the Perea town site, and all along the base of the Vermilion Cliffs, right outside the La Quinta area here. And it comes above ground at the waterfall in Upper Steer Gulch. Now, one interesting thing, zircon grains tell us where these rivers originated. The zircon is a microscopic crystal that originated in a granite rock, and these crystals have unique chemical signatures and can be dated. So if you find these zircons in something like the Chinle Formation in the monument, what you can do is you can trace that back to a known outcrop of granite, and these happen to be in Texas down in here. There was a mountain range in Texas, and you can see these rivers coming out of there and going that way. They have actually found zircons from the southern Appalachian Mountains in the Chinle Formation. And this is just an incredible way for us to understand the origin of these rivers. This is from the head of Long Canyon looking towards the Circle Cliffs. You can see the Henry Mountains in the background there. This is a big circular uplift. The rocks in the middle of the uplift are lifted higher, and they've been eroded out of the center. But right in a ring, right around the base there, is the petrified forest member. I wonder how it got its name. It wasn't for the Wolverine Petrified Wood area, it was actually for the national park, the Petrified National Park, where the layer still is exposed. This is probably a scene of what the Chinle rivers look like. This is a picture in Peru of the Amazon River, a very low-lying floodplain. This could be a little bit too wet for what the Chinle was like, but it's probably a good modern analog for the geologic setting. One of the most interesting things about this next layer, the Moenavi in the west and the Wingate in the east, these are two different rock units, and depending on where you're at in the monument, you will see one or the other. And it's the paleogeographic map that reveals how. You can see that this is just a little bit later in time than the previous map, but we still have rivers headed to the northwest. This river system right here was a distributary system, much like we have at the mouth of the Mississippi River today. And if you visit the Echo Cliffs, Tuba City, on through to Zion National Park, you will have the Moenavi Formation exposed. And I've drawn some circles here. The blue circles represent the deposition of the Moenavi Formation. At exactly the same time, the Wingate sandstone was being deposited here. So if you were in this ancient landscape, you could travel from this riparian area where the Moenavi was being deposited and then climb up into sand dunes that were like the Sahara Desert. And these two units sort of interfinger with one another, and they change in the subsurface between the Echo Cliffs and Monument Valley. This is a really interesting story to tell folks. Now the picture there in Long Canyon where you see the road going through the snow, that's the Wingate sandstone. So we would be in this part of the ancient environment right here. When you go to Zion National Park, or right here at the Vermilion Cliffs, right behind the hotel, there is no Wingate sandstone. It's the Moenavi Formation here. This one little item about how a formation can be related to another one laterally, but they have different names. That's how we get people to change their major from geology to modern art. This is the type of thing that can confuse people, and I appreciate the fact that you might be confused that two different rock units are of the same age. But let me give you a modern example. If you were to sample the sediment on the west side of the Florida Peninsula, you would find muddy and shaly deposits. If you go to the east side of the Florida Peninsula, they're going to be more limey. Those are two different rock types eventually that are being deposited at the same time, but because of the environment that each of them exists, they might get different formation names at some time in the future. And who knows about this little slot canyon there? This is one of my favorites. I think everybody likes this little place right there. This was an April trip that I did one year with the Museum of Northern Arizona, and we just had, I won't say horrible weather, we had interesting weather. It made it into the slide program. I used to take my groups up into Upper Steer Gulch, just to the east of Deer Gulch, and you walk through the Wingate Sandstone, and you get to a place where you see the very top of the Chinle Formation, and then the Wingate is on top. Now remember, this is a river deposit. These are shales and mudstones. And if you look on top, you see the sandstone here with the angled beds. This is a sand dune blowing in on top. So if you could magically transport yourself back in time, right to this point right here, you might be standing on a muddy floodplain, but what's coming in right off to your left shoulder is a sand dune being blown in by the wind. And there's some really detailed textures in this photograph right here, and I'm especially pointing to these very thin, light-colored beds. Those are wind-blown sand on the leeward side of a sand dune. You get a little light wind blowing, and it's just going to blow a little sand on that crossbed right there. The darker beds that are thicker in between is where the dune has avalanched down as it got over steep. And these are called sand flow toes. And when you look in these Aeolian sandstones, it's just wonderful to see detail like that. Probably the best rock unit in the whole Colorado Plateau is the Navajo sandstone. There's a picture of the Peekaboo area. By the way, these are the newest maps that Ron Blakey has made, and they're going into the second edition. But this sand sea went all the way from Tucson, Arizona, all the way up to Montana. And this is the largest fossil Sahara-like desert we have on the planet. It was just a very extensive area of dunes. There's Calf Creek, and you can see the ledgy stuff right down by the creek. That's the Kayenta Formation, and then the Navajo goes above it. In the Dry Fork of Coyote Gulch and elsewhere, you see these little pimples in the Navajo sandstone. Some of you might wonder what that is. Those are iron nodules, and they eventually, when they weather out, become the Moki marbles. And it's thought that there might have been petroleum when this was all buried that moved through there and mobilized the iron in the rock, and then it reprecipitates around a nucleus to create these hardened pieces of sandstone. So all it is sandstone like everything in between, but it just has a higher concentration of hard iron cement. This is a pretty old picture back from the 90s of the line cabin down in the Hole in the Rock Road. These are called water escape structures. You can see the cross bedding here where the dunes were forming, but notice how it's deformed up there. And if you were to get a little earthquake when this stuff was being deposited, the water in the sand would become mobilized and it would shoot up like a geyser like that and deform the beds. A lot of times in the Navajo, you'll see thin beds of limestone, very pure limestone. These are oasis deposits. There were oases in the Navajo desert, and in between the dunes, the water table would rise high enough that algae could grow in a very shallow lake, and the algae secretes limestone or calcium. And these are just deposits from an oasis. And then this is from the Coyote Buttes area, just looking at some tremendously large cross beds. Remember, the way the beds dip is the paleo wind direction. So as you look at this diagram here, the wind was blowing from right to left. And the way that that works is the sand grains climb up the windward side. When they get to the crest of the dune, it gets oversteepened and they slide down the leeward side. And through time, the dune migrates across the landscape. So you're actually looking at the migration of a dune. And you see where these thin beds are sticking up with a little shadow underneath them? That's from the wind whipping around on the back side of the sand dune. Everything else is the avalanche coming down. Just spectacular preservation. And there's a Navajo sandstone in Coyote Gulch sitting on top of the Kayenta Formation down below. The Kayenta is always ledgy. Sometimes it'll have a bed that looks like Navajo sandstone. By the way, I should mention, probably the hardest thing for people to approach geology is that you go to an outcrop along the Escalante River and you wonder, oh my God, is this Wingate? Is this Entrada? Is this Navajo? The best way to tell where you're at in this stack is to look what's above and below it. Because God never shuffles the deck. The Moenkopi is always below the Chinle. And if you've got something that's the Chinle and you see these red beds below it, it's got to be the Moenkopi. And the Wingate and the Navajo and the Entrada, they all look alike. If you have a hand sample of any one of those, you can't tell which one it's from for the most part. I'll never forget a funny story. You might have heard of Katie Lee, who was a very interesting person from the past, who was a musician and an actress and just a firebrand when it comes to Glen Canyon Dam. She sent me a picture one time and she said, Wayne, is this Entrada or Navajo sandstone? And I thought for a second, I go, oh God, it's just a close-up picture of a sandstone. There's no way to tell. So I wrote back to her and I said, I really can't tell, but if I had to guess, it must be the Navajo. And the next time I saw her, she was just laughing and she wouldn't stop. It was not a picture of sandstone. It was a picture of her 96-year-old leg and the skin on her leg. And she loved the idea that she fooled the geologist. And every single time I saw Katie Lee after that, she wanted to tell that story, that her skin looked like Navajo sandstone. Now, what happens at this time in the Jurassic is that the Sundance Sea starts to come down from the north and starts to flood down through the Wasatch Front and actually comes down into the area of Zion and the western side of Grand Staircase Escalante. The next period in time, you can still see that Sundance Seaway there, but there's more dunes around it now, and this is the famous Entrada sandstone. The Arches and Arches National Park are cut from the Entrada, and these little hoodoos that are found at the Devil's Garden are also carved in the Entrada. And then finally, Alan was talking about this a little bit. This is the Morrison Formation, very typical for one of the members to look a lot like the Chinle. If you're going to get confused between two rock units, the Morrison and the Chinle look very similar. But again, the only thing you need to look at is where are you at in the stack at this point. I mean, if there's Entrada, if there's a sandstone underneath this, then you know you have to be in the Morrison, because beneath the Chinle, there is not that light-colored sandstone. It's the sequence of rocks that will really help you to differentiate what you're looking at as you drive across the monument. And I said that God never shuffles the deck. The layers are always in the same order, but there are faults and folds, and that's where the trick comes in, is identifying where the faults and folds will bring things. Now, we're just going to look at this western interior seaway that Alan referred to earlier. This is 93 million years ago. The Arctic Ocean has flooded in from the north, and the Gulf of Mexico has flooded in from the south. This is where the Rocky Mountains will be eventually, but just 93 million years ago, it's below sea level. And there's active tectonism happening over here on the west coast of North America, and it's on these plains at the foot of the mountain where all this dinosaur fauna is found. And what I have here is a little time lapse to show you at about 5 million year intervals through this period of time right here. These are with the newest maps that Ron Blakey has been drawing. It was on these floodplains right here where all the great dinosaur fossils are coming from. You can see the mountains that existed to the west of the National Monument right here. And then we eventually get to this period in time, 50 million years ago. The seaway has retreated away. The Rocky Mountains have been uplifted. And between the old mountains on the west and the Rocky Mountains that have formed on the east, we get these giant freshwater lakes. And if you've been to any of the rock shops and seen the fish fossils, they come from these lakes. And this is the lake right here, Claron Lake, where the rocks at Cedar Breaks, the Aquarius Plateau, and Bryce Canyon were formed in that particular lake. We don't have exposures of that rock unit that could connect these lakes. It could be that some of these lakes were connected at various points in time, but they existed about 8 to 10 million years in geologic time. So I just thought I'd go back and show you some pictures. This is, we used to call it the Dakota sandstone, but Jim Kirkland has told us to call it the Natarita on this side of the seaway, and then mostly the Tropic Shale. In Colorado, they call it the Mancos Shale. And these mountains that you see here, notice how linear they are. These were thrust sheets, and as this oceanic plate is pushing on the edge of the continent in this direction, it's taking layers of rock and folding them like a piece of paper. And all throughout Idaho and western Wyoming, western Utah, Nevada, you see these giant thrust sheets where once flatline strata have been folded and moved onto each other. And sometimes rocks can be moved 50 miles from west to east in these folding events. Those were the mountains that were being created, and because the crust was getting thicker at that time where the mountains are, it depressed on the crust here and caused this seaway to form. Love the Straight Cliffs. It's just one of my favorite landforms in the whole Southwest. And when you're driving out of Boulder, Utah, and you're going towards the Straight Cliffs, they're so well named. And then in 1931, some geologists named that rock unit after the landform. By the way, anytime you have a name for a rock unit, the name refers to a place where the original geologist studied that layer. So you always know where it was first described. And then the Kuiperowitz Formation that Alan was talking about, where all the great dinosaurs were preserved. And finally, the Claron Formation, these freshwater lake beds that are about 50 million years old.
So when they were I'm sorry.
Yeah, that's okay.
When they were the Sundance stuff, they were saltwater and now they're freshwater?
Yep.
Okay.
That can be a very difficult thing to understand.
Yeah, but it makes sense.
Yeah. The reason it can be difficult to understand is because people who were not geologically aware, I'm speaking about most people in the world, there's only two moments in time. There's the time they're living in and everything that happened before them. And everything that happened before them is just this one amorphous thing in the past. And when you start to realize that each one of these rock units is differentiated from what's above it and below it because something changed in the environment to cause the sediment type to change. And so as you become a geologist, now when you look in the past, you go, oh my God, there's millions of time slices back there. And even if you take a short period of time, say 5 million years, you could change things now and then so that you have a freshwater lake at the bottom, but if the sea comes in at the top of that, then you're going to have a saltwater deposit on top there. So just remember, many, many moments in the past. In the last 2.5 million years is when we had the great glaciations. You can see the Sierra Nevada is completely glaciated, but in this diagram here, here's the Aquarius Plateau and the little glacier that used to exist on top of it. And there are some really interesting glacial deposits from Boulder Mountain that have been documented. And this is the landscape we all get to play on today. There's Grand Staircase, Escalante National Monument. You can see this kind of topography out here in Nevada and western Utah. Prior, 20 million years prior to this, all of this area right here was closer to the Colorado Plateau, and everything's been extended in the basement range. It's been stretched 100%. It's twice as wide now as it was 20 million years ago. Okay, just a little bit about Uplift. This is looking south on the Cottonwood Canyon Road. This is called the Coxcomb, and you can see there are resistant layers, probably of sandstone right there. That is a once flat-lying bed of sandstone. There was a monocline that was formed such that the Earth's crust was bent, and now what is happening is streams are coming off the mountain on the left, and they're slicing through this upturned bed. And if you look at my fingers right here, the streams are going in the gaps, and that's why you see that ridged nature right there. It can be very, very difficult to explain to guests how something like that forms. And believe me, it took me many, many years to figure out the best way to do that. And you have to do it sequentially. You have to say that bed that you see sticking up like that, like a stegosaurus back, used to be flat-lying. It was tilted up as a continuous sheet in the subsurface, but only in the last 1 million years have streams been coming off the mountain on the left, slicing through that upturned bed, and you're looking at the spacing between the streams. Your eye is drawn to the interfluve. That's the word you use for the ridge in between the two streams coming down. Your eye is drawn to the interfluve, but it is the stream cutting through that gives it that technique. And this is the reason that we have these monoclines on the Colorado Plateau, is that we think there was a segment of crust in the Pacific Ocean. Most of the segments have a steep dip, and they go down just a short distance from the coastline, but there was a segment that had a very shallow dip. It inserted itself beneath the crust, and when it inserted itself beneath the crust, it uplifted the Colorado Plateau. And this is a really simple way to explain uplift. Although there is no simple way, this might be the simplest way to explain. And then finally, we have erosion. Did you know that if you want to understand this landscape through time, and you want to run a film backwards to understand how the landscape formed, the very first thing you have to do is remove the deep canyons. You have to remove the deep canyons. They have probably only been here for 5 to 10 million years. And I believe that if you were on this landscape 5 to 10 million years ago, most of the things we see were in place, including that fold along the Coxcomb, but it was buried under a beveled surface. And it would be a very, very subdued surface with a few little promontories sticking up. And beginning about 10 or 5 million years ago, the Colorado River finally made its way to the Gulf of California, lowered the base level that the river was flowing through, and it was like pulling the plug. And once you pull the plug, the river starts to slice down into these rocks, and all the tributaries eat their way back up away from the main river. That's a good way to explain the very, very last thing that has happened on this landscape. Pulling the plug with the Gulf of California, and then you get something like this. Anyway, I look forward to signing one of these books for you when the time comes. Thank you very much.